right. Thank you for the introduction. And as you heard, my name is Alain, or Alain in French. And this is going to be a short talk all about Angular signals. So we can really try to go as deep as possible in 20, 25 minutes and give you a great overview of what signals are all about. So I'm Alain, I'm a GD in Angular and Google Maps. I've been working with Angular for a very long time, started back in 2011. And these days I do mostly training and consulting around the Angular framework. I teach Angular and I help people build complex Angular applications with the framework. So why signals? You've probably heard about them. They're becoming more of a buzzword around Angular these days. And the idea is really that signals are going to be everywhere very soon. So it's very important to really, jump on that boat and get on board with signals, because they are really changing the way the framework is going to work in the future, in a sense, and also going to change the way you architect your applications. So what's the idea behind signals? The idea is to have reactivity everywhere, meaning if you've done any Angular for any amount of time, you know RxJS, you've worked with observables, and you also know that RxJS is not easy to learn. There's a lot of complexity around operators and subjects and all of that. Signals are the easy version of RxJS. Let's say that if you learn signals, it's going to be a lot easier, a lot faster to get into it than using RxJS. And as a result, you can really use them all over the place without thinking twice about it. Another big thing about signals is it's very lightweight. It's only 2 kilobytes of code, very fast. No need to worry about adding a third-party library. They are part of the Angular framework. And the last one is precision updates, which I'm going to cover in more details here, because if you use Angular right now, the default change detection in Angular works like this. And what happens is if you click any button, if there's any event going on in the browser, anywhere in your component hierarchy, then the default change detection is going to have to check every single component from top to bottom, right? And it's not perfect, of course, because if the changes impact just one little component in this component tree, Angular doesn't know about this and still has to check every single component. So it's a lot of work, especially if you have a bigger application with a complex hierarchy. So as a result, the key thing is that change detection is something that the Angular team is trying to improve, and signals are going to be key in achieving this. Because when we use signals, the idea is that Angular knows exactly which component, and even more precise than that, which view, and I'm going to define a view in a few seconds, but every single, let's say, piece of HTML template that depends on a specific signal, Angular is going to know that. And as a result, when we change the value of a signal, Angular is going to be able to update just that small part of HTML template that depends on that signal. And if there's many of them, it's going to update all of them. So a view is a subset of a component HTML template, if you will. And as a result, change detection is as precise as possible, right? The scope is really as tiny as it gets. And Angular knows exactly which part of our templates depend on which signal. And when we update that signal, these are the only parts of our code that get refreshed. So that's where the big revolution is. It's that super precise, optimized change detection when you use signals that you don't have any other way in Angular, right? You could try to make this happen by asking for Angular to do change detection and kind of doing it manually. This is all automatic, and this is as precise as it gets. So This, by the way, this new change detection that's signal-based is now in developer preview in Angular 18. So it's all fresh, and you can now use that to test how it works and see if there's any performance benefits on your application, for instance. So that's really super important to remember. Change detection is going to be unlike anything you've seen before. Completely new, really super precise, super fast, and as optimized as it gets. That's one of the key features of signals. So making things faster, making things easier to learn, having just a bunch of familiar, simple concepts to learn about, and then still keeping everything interoperable, meaning the code that you have right now with RxJS can still work with signals, and using signals can be a progressive thing. You can go step by step. You don't have to do everything at once. And in the end, it works great with existing Angular apps, backwards compatible in a sense, because you can have that interoperability with RxJS, which is something we're going to cover in a few minutes. So how to use signals. Now let's get into the code and the API behind signals. There's really three basic things to know about. Three reactive primitives or functions: signal, computed, and effect. I'll start with the first one, signal. So signal is a function that creates a signal. And when you use it, it creates that new object that wraps a value. A signal is just a store for a value, and it has this extra power of automatically notifying every single dependency when it changes. So I want to show you a very quick demo of a basic signal. Here I have a component, and in that component, I create a signal using the signal function that I just mentioned. And this creates a signal with a default value of Angular in that example. And then in the template of my component, I want to read that signal. So to read a signal, you call it as a function, just like this. So my signal is name. I want to read the value. I call name as a function. And this displays the value. So we see hello Angular up here. If we want to change the value of a signal, there's a setter. There's a set function on the signal object. So here we have this button. And when we click it, I want to change name to world. So I just do name.set world. And let's do that. Click on that button. You can see that now we see hello world up here. So the value of my signal was updated and automatically displayed instantly. So that's how you create a signal, read a value from it, and update it. And that's it. There's no subscription, no unsubscription, no operators. All of that is gone compared to RxJS. It's just, one function to create it, one way to read it, one way to set a value, and done. I said one way to set a value, but that's actually not true. There's two ways to update the value of a signal. The first one is the one I just mentioned, set. So set allows you to set a new value to that signal. And the second option is update. And update is when the new value depends on the previous one, when you want to derive a new value from the current value. If you have something like a counter that you want to increment, for instance, that would be a good use case for update. So here's an example with update. Create a signal with a value of 1. You want to update it by incrementing the value, pass a function as a param, and current value return current value plus 1. That's a good use case for update. And once you know that, that's it. You know how to create a signal, read its value, and update it. And you're almost all good to go. Now you're probably thinking, okay, that's good. I can create a signal, set a value, read it. But then how does that replace all of the other things that RxJS can do for me? And when we use RxJS, we have plenty of operators to combine different observables into one thing, or to do some mapping and filtering and all of that. With signals, the equivalent for this, and the one function that replaces all of the RxJS operators, in a sense, is called computed. With computed, you create a new signal that derives value from other signals. Let's take a look at a demo for this. So in my example here, now I have two signals, one that has a greeting, default value is hello, one that has a name, default value is Angular, and then I create a computed signal using a computed function that creates a new string derived from the two values of these other signals. So greeting and name. And just that line of code, that simple syntax here, automatically understands that if greeting changes or name changes, then we need to compute a new value, and this message signal is going to get updated accordingly. So you can see that this replaces lots of complex use cases with RxJS, and it can be done with just one function, and in that case, one line of code, which is perfect. So let's see it in action. So same stuff as before. I have a greeting, which is just a message. So this is a computed signal that says hello Angular up here. And then I never update it directly, this signal. I only update name or greeting. So if I set name to world, you can see that the text up here says hello world. But this update comes from the computed signal that depends on name and greeting. And if I change the greeting to welcome, then it says welcome world. So I can change the greetings to different values, and as I click, automatically this gets updated and the computed signal gets a new value. That's really how easy it is, because all I have to make that reactivity happen is those three lines of code. I create two signals, I create a third one that depends on the two first signals, and then when things change, it's all reactive, it just happens. So that's computed, and there's one last function, which is maybe a little bit less useful. It's called effect. Effect is somewhat similar to computed in the sense that it's going to run when one of the dependencies, when one of these signals that you have in the effect function gets updated. The only difference between effect and computed is that effect does not return a value. It doesn't return another signal. So I use effect in that example to run a side effect, which is just logging the update to the console. So I use effect, and in my function, I say console log message change to this.message. So I read the value of a signal, and reading the value of a signal automatically registers that signal as a dependency of effect. And so if we go to the console, you can see that there's many console logs when I clicked these buttons earlier to change the message to welcome world or hello Angular, and every time I clicked, this got logged in the console. So that's effect. And once you know about these three functions, you know the signals API. That's it. We did it in what, 10, 15 minutes? So it's pretty impressive, right? The learning curve of signals is very short. We just did it all in just a few minutes. You don't have to learn about operators, subscriptions, unsubscriptions, subjects. That's the API, effect computed signal. Now, of course, there's different types of signals that come with the library, with the Angular signals from Angular core. By default, when we create a signal ourselves using the signal function, that signal is actually of type writable signal, meaning you can write in it, you can change the value. And as you can guess, when you use computed, the signal that gets returned is read-only. It's not a writable signal because the value is automatically computed by Angular. So we have writable signals and we have signals that are not writable. And you can also create your own signal. That's what I do here. And expose it as a read-only version if you want to. So that's the line of code we see down here using as read-only. So that way you can do something with the signal inside a service, for instance, and then just expose a read-only version to your components so they cannot change the value themselves. They have to use the service. So the service is kind of the brains that decide how to change the value of the signal. And then components can just interact with getters and setters in a sense. What else do we have? What about RxJS in that picture? Where does RxJS fit now? Well, RxJS is still here. It's not going to go away anytime soon, but we can expect Angular APIs to use more and more signals and start replacing RxJS with signals, which has already happened in a few places. I'm going to talk about that in a minute. But if there's just one place where you can start using signals is as a replacement of your subjects. So if you had a service like this one, for instance, where you have a behavior subject with a default value, and you would expose that subject as a read-only observable, doing the equivalent with a signal looks like this, where you create a signal of that same data. Then when you want to update it, you use a setter function. And if you want to update, to expose it as read-only, you create a getter function returning your signal as read-only. And that's it. That's my translation from subjects here to signals down here. Same amount of code. The translation is pretty straightforward to do. Now, this was for subjects specifically. You're probably thinking, what about my HTTP request using the HTTP client? Well, if you want to convert those into signals, there's a toSignal function. A toSignal function takes any observable and turns it into a signal. There's the opposite too. If you have a signal and want to turn it into an observable, you can do that. Why would you do this? I don't know. I would rather turn everything or as much as possible into signals, but there's a function to do the opposite as well. So you can really have that interoperability and do one or the other using these two functions. And so yeah, one key difference to have in mind, though, when we use signals versus RxJS is that an observable is asynchronous and a signal is not. A signal is always synchronous. A signal always has a value, always returns something. That's why we don't have to subscribe and wait for the data to be there. A signal always has a value, which means by default, if you don't pass a default value, the value would be undefined. So a tip on that, especially if you work with HTTP request, you might want to pass a default value. So here we turn an observable into a signal, and we pass an initial value, which would be the default in the short amount of time that we wait for the HTTP response to be there. This would be the initial value. And that way it's never undefined. There's always something in that signal. What about NGRX and state management libraries? Nice and easy. They are adopting signals as well. NGRX started with the signal store in version 17, and they also have a signal state. So both options are available in NGRX for state management using signals. One is lightweight, that's signal state. One is a little bit more complex and has effects and methods and all of the Redux-like concepts from NGRX. And that's the signal store. So these two are already available, and you can use that if you want to keep using state management on top of signals. What's next for signals? First, it's important to remember that they are officially available since version 17. And as we saw, the main thing is that since we're going to have that local change detection with signals, it makes Zone.js optional, meaning Zone.js was the library that would detect changes, that would detect that your user clicked somewhere or an event happened in the browser that would trigger change detection. So this can become optional now. And then simplifying Angular's APIs, reusing signals instead of observables everywhere where it's possible to do so. So that's what's happening right now in Angular. That's the direction in which it is going. And one of the main one of the places where it's going to be the most visible is inside our components, where we now have that concept of signal-based component, where everything is based on signals, inputs, outputs, content queries. So this is an input, a signal-based input. This is available in Angular right now. You just use that input function instead of the input decorator, and it turns your input into a signal. Also works with two-way data bindings using a new concept called model. So it creates a signal that's both an input and an output. Really, that's what it is. So you can use the banana in the box syntax for the two-way data bindings using model. That works perfectly fine. And output, same thing. They removed observables from the output mechanism, and now it's signal-based when you use the output function. So that's one of the first steps of removing RxJS slowly and replacing it with stuff that is not RxJS anymore, mostly signals. Content queries. So if you use view child, view children, content child, content children, same thing, they all have signal-based equivalents now, which are simple functions with the same name. So view child, content child, and the query that you want to have in here. And so, yeah, that's really everything I wanted to talk about signals. There's a lot going on. It started with V15 of Angular with the first research and prototyping. V16 gave us a developer preview. 17 brought support with inputs, outputs, queries, and the first signal-based APIs. And with V18, now we have the first previews of what could be a fully zoneless application. And this is going to keep evolving in the future. We can really foresee a future of Angular without Zone.js, maybe without RxJS even. That seems ambitious, but the Angular team is definitely going in that direction, and even mentioned being able to use Angular without RxJS in the future. So that's why signals are super important. And that's why, I recommend people to really get into now, because it's going to only become bigger and bigger, and really rethink the way we build Angular applications using signals instead of RxJS for reactivity. So I want to thank you for your attention. Listed a few links here if you want to reach out. My blog, the free monthly Angular workshop that I do at courses.angulartraining, and the free weekly newsletter. So if you're interested in any of this, feel free to reach out. Let me know. Always happy to answer questions from people. And yeah, hope you enjoyed this short talk on Angular signals. Thank you.
Exactly. Hey, thanks for this amazing short talk. I didn't know that we had such many features released with Angular. That's quite impressive. And you know what's more impressive? The questions that we have. So how does the signals API affect the complexity of code bases, particularly in large-scale applications?
I think it will really simplify the complexity of code bases, because if you have a large code base, big application, most likely you have RxJS and you have a lot of operators. And these are difficult to understand, difficult to maintain, especially when you get new developers in the team. It's tricky to get them up to speed with all of that. Yeah. Signals, we saw there's just 3 functions. So it's hard to get it wrong. And in terms of complexity, it's only going to make things easier, I think. So it's really something to welcome and really emphasize that it's going to be a lot easier.
Yeah, that's also why Tailwind was such a success, because people use Tailwind and you don't really need to learn something specific. Everybody kind of uses the same thing, so then you get started faster. So yeah, that makes a lot of sense. Second question, can you share some real world examples or use cases where Signals API has been successfully implemented?
Yes, the best one I think is YouTube. So everyone uses YouTube, right? It's probably one of the most popular Google products that's out there, except Google search maybe. And YouTube is now using Signals everywhere. Yeah. So think about the biggest app used by millions of people every day that cannot fail, has to work. That would be something like YouTube, and it's using Signals right now. Interestingly enough, YouTube is not built with Angular, but it's using Angular Signals anyways. So that's some a very good real world example where it's pretty successful.
Yeah, and also it shows that it can be agnostic and used in a lot of contexts. So that's very nice. What tooling or libraries are available to support the use of the Signals API?
Well, the nice thing about Signals is that libraries, you don't really need them. It's kind of the opposite. The idea of Signals is to make things easier. So we don't need a third-party library to assist with that. We don't need something like RxJS anymore. So there are some libraries like NGRX, Signal State or Signal Store if you want to do state management on top of Signals. And other state management libraries go in the same direction, start using Signals. So that would be some of the toolkit you can get. And in terms of, let's say, debugging, tooling, all of the major IDEs all already support using Signals and provide assistance, autocomplete, and those kind of things. So if you forget a parenthesis to read the value of a signal, it's going to tell you, hey, you're using a signal here. You probably want to read the value in that template. So it's going to help you already do that. So the ecosystem evolved really quickly and is already all up to date, which means I don't think you need any other tool or library. It's all there.
Yeah, and that way you have less dependencies, so you don't struggle to update it and like follow the vulnerabilities or anything specific. So
exactly.
Yeah, that's very good. There's one person asking if you could share the slides somewhere. Because
yes, I can definitely.
Perfect.
I guess the person can send me an email and I'll send that because it's going to take a couple of minutes to create the link. Perfect. I don't have it right now, but yeah, I can do that for sure.
Another one. So Signals bring Angular closer to how React was valid to reactivity. And I always wondered why I need a third-party library. So yeah, this one's a bit answered. But what's your take about React and Svelte regarding this?
Yeah, I'm not that familiar with Svelte, but I'm familiar with React, and I would say that the change detection is even more granular with Angular Signals because it's not even at the component level; it's at the view level. So the framework knows exactly which part of your HTML to re-render when a signal changes. React doesn't do that. For instance, React would have to, rebuild the virtual DOM and do that comparison, which is work. But Angular doesn't even have to do comparisons anymore. It's just, this value changed, we use it here, so let's update it here and done. So that's really a big deal. And again, no third-party library, it's all native. Perfect.
Maybe Solid would have been a better example here, but maybe you don't have experience in Solid either. So yeah, I know that, for example, Vue.js was using something similar to Signals, and now they are officially moving to Signals in their internal API. So that's it's quite nice.
Okay.
Is it safe to assume we convert to Signal for all the template variables? We used to declare a component with this keyword earlier.
Yes, that's a safe assumption, especially if it's a variable that's supposed to change over time, right? If it's something you just assign a value once and then display it,
just static.
It doesn't make sense to make it reactive with a signal. But if it changes, yes, then just wrap it into a signal. It's almost free, and yeah, you get the benefits of that automatic change detection that makes things faster. Yeah.
last one, which might be tricky, Redux and signals. I'm not sure if you use Redux since you don't.
Oh yeah,
React.
that's a $1 million question.
Yeah, let's go.
I would
Do you want
say,
to call a friend or like 50-50?
yeah, no, I'm fine with answering it. Actually, on Friday, I'm doing a Forge exercise on this to show you how to build an entire feature. So at Frontend Nation, we have that workshop on Friday where we're going to work on an exercise where we build an entire feature using signals and interacting with RxJS and all of that. So, you can join that event and you'll learn more. But yeah, to me, the need for a store is almost absent with signals. It's only if you really want to define a clear pattern that all of your developers are going to share that using a store would make sense. So it's more like for the convention aspect of it, or everybody is doing it the same way, that a store would help. But other than that, I don't think you really need it anymore, right? And that's another thing that can be simplified a lot thanks to signals. Yeah.
Perfect. I wasn't able to find a sound effect of Who Wants to Be a Millionaire for the question. But the good news, at least, is even if this day is over, we're going to see you very quickly, and we're going to get even more practice with this. So thanks again for this, Alain. And I wish you an amazing day or evening, or yeah.
It's noon for me, so it's lunchtime.
Okay, perfect. Have a nice lunch with a baguette.
Thank you.
Bye-bye.